Great. So the next piece which I want to talk about is your route leaking, right? So route leaking. So before doing route leaking, let's do summarizing, right? So we have done summarizing before, so let's do summarizing here. So let's go down to my R5, right? So what I'm going to do is let me clear the screen a bit, and we know that we have this network, show IP interface brief. So we have this 105 network, right? And we are trying to summarize that. So how do you summarize the 105 network? We have done this before. So we are going to summarize it in both the directions, on towards R4 as well as towards R6, right? So let's do that. So let's go down to interface serial 1/0 and IP summary address EIGRP 100, and the address is 105.1.4.0, and the summary mask would be 255.252.0. right? Now the 4 routes are not going to go, we'll just have 1 route. So let's do it on the other side as well. Other interface 1/1, is it? Yeah, the 1/1 interface, and on that it's going to be the same command, right? There you go. So we have done this. So on my R6 now, if you look, right, because I have summarized, R6 will be getting 2 different routes coming in from, right? One will be coming in through this and the other one will be this. And like I said, R6 will put the best route in the routing table. So let's look at that. So if you look here, let me clear the screen, show IP route. So if I do a show IP route, you can see here, where is the best route? See, you can see the best route, it's summarized route, and there is only one route in the routing table, which is obviously coming in through or via this path, right? And that's basically put here. But now if you observe the topology, you can see that this link is not being utilized at all, because all the data packets are going to this path, right? Whereas this one is not being utilized at all. So how about we manually leak some routes, right, of R5 along this direction, right? So that's what we are trying to do now, right? So we are going to leak one specific route, probably the 105.1.6.1. So we are going to leak this route along this path, right? And we'll see what happens, right? So let's get started. So what we'll do is, this first step 1 is to classify the route, which route we want to leak. So let's go down to R5. So if you go down to R5, let me clear the screen, probably put in an access list, right? So let's do access list 1 permit which route we want to leak. We want to leak 105.1.6.0 and 00.255. there you go, that's the access list. Now we define a route map, right, where we attach this access list. So we say route map ABC, match IP address of the access list which we have defined, it's 1, so that's a route map, and then use the leak map or the route map, whatever we have defined, within the summary, right? Yeah, so which interface are we looking at? We are going to do it on the interface serial /1/1, right? And IP summary, sorry, not auth, summary address EIGRP 100, and so I think we already have a summary address, summary interface configuration here. Let's just remove that and put the new one. So how do I remove that? Let me see. Do show run interface serial 1/1, right? So I just need to just remove this once and put it back on, right? But with some small change, which is you have to now attach the leak map, right? You need to attach the leak map, which is ABC. There you go, right? So if you look at the interface now, let me show you how it looks. Do show run interface serial 1/1, right? So this is a command, right? What did we do? We created an access list. We attached the access list to a route map. We called it as a leak map, and that leak map has to be attached here, right? So we are still summarizing the. It's still going to be the regular summary command, summarisation command, right? Where we are summarizing the whole network or the 4 addresses into one single. This is the summary address and subnet mask of it, summary mask of it. but at the same time we attach a leak map saying, go and leak this particular route, right? So now if you go down to my R6, what do you see? Let's clear the screen. So if I do a show IP route now, you can see, let's look at the 105 network. So you can see here we we still have the summarized route coming in from where, from this path, right, along the serial interface 2/0. Why? Because it has the lower metric, right? You can see this metric which we earlier calculated, it's still the same. Whereas there is another route which has creeped in, or which has sneaked in into my routing table, and it is the route which I leaked from my R5, right? So this is how you can actually leak a particular route into my into my routing table. And you can also observe that there is a different metric. The metric here is very similar to this, because it is coming in along the direct path, right? Yeah, so you can also look at what path it is taking, right? So if you want to do a trace to probably 105 dot 1 dot probably 4.1, I believe that's the address, right? Do show IP interface brief. Yeah, it's 4.1. So if I do a trace to this, okay, taking a bit slow, but still it's good. So you can clearly observe it is taking which path? 46.4 path, isn't it? Right? It's taking this path because I did a trace to 105.4.1. But what if I do it for 6.1, right? This is basically the leaked route, and you will see that it will basically go along this path and not this path, right? Because at the end of the day, what is it? It basically follows the longest prefix match rule, right? So if you look at the routing table of my R6, you might argue that, hey, if you look at these two routes, you can see the subnet mask here is 22 and this is 24, right? So when I do a 105.1.6.1, when I do a ping to that particular route from here, it qualifies under this route as well as this route. But which one does have a longer prefix mask? You can see this is 22, this is 24. So that's why this will be preferred over this particular route, right? If this particular route leaking did not happen, then all the routes would have taken this path, and all of them would have gone in the along this direction, right? But because I've explicitly leaked this particular route, and that route has creeped into my routing table, it has a longer prefix match as well, right? It has as a result of that, it will take this route, right? So that's how you can leak routes, right? So that's route leaking. So 3 steps: you basically define an access list, you define a route map, and then you attach your inside your summary address command, you basically attach the leak map to it. That's it, as simple as that. Okay, now let's look into what you call as the named mode, right? So till now whatever we did is the EIGRP configuration was basically a classic mode of configuration, right? So in classic mode, the EIGRP configurations are scattered all around the router mode, interface mode, and so on. The named mode is a way of configuring EIGRP. This mode allows EIGRP configurations to be entered in a hierarchical manner under the router mode itself, right? So maybe we could try this on let's go and do this on one of the router, right? So let's do this on probably R1 and R2, right? So we already have let me clear the screen a bit, right? So if you do a show run section router. So this is the classic configuration of EIGRP on router 1. So let's try to convert this. So do we already have let me just see, sorry, my bad, show IP EIGRP neighbors, right? So it is already having neighborship with R2. So now what I'll do is I'll remove this. I'll do no router EIGRP 100, right? So when I do this, the neighborship on R2 would basically go down. It's gone down. Now let's go back and configure this using my named mode. So how would I do that? I would say router EIGRP ABC, right? Then the address family IPv4, IPv4, right? Autonomous system is 100. What else? We will also advertise the networks, which is 10, probably the 11, and the other one being 101. There you go, advertised it. And now the interface related configuration, right? You can do it here only. This is the beauty of named mode. You do every single thing under the router command, right? You want to summarize some network, you can do that as well. Let's summarize it. Probably 1.4.0 and 255, 255, 252.0, right? Authentication, we have authentication put up on R2, so we'll have to do it here as well. And authentication keychain is going to be ABC, right? So you can see here the neighborship came up, right? So now if you look at the whole configuration here, show run section router, right? You can see that every single thing, every single EIGRP related configuration is in one place, right? It's one stop kind of a place. So you want to do any troubleshooting, you just need to come and do it over here. You don't have to go under each and every interface and do search for the configs. You just come down here, look at it, and try to fix it, right? So it really helps in troubleshooting. The other point which I also want to talk about, the advantage of using named node, is that it also supports currently if you look at the authentication, it supports just MD5, right? Or you would have thought, or we have used only MD5. So in classic mode it was supporting only MD5, but in case of my named mode, I can also use the SHA, right? SHA is considered to be kind of like a little better version of my MD5, right? So it is more secure and more better hashing. So I can use SHA as well. I'm not going to show it here, but I just wanted to call it out because that is another advantage of using my named mode over my classic mode. Great. So I think we are probably moving down to my last concepts of the day, which is going to be my EIGRP load balancing, right? So load balancing, so for that we will, I think I have a small topology here, yeah. So I have not configured anything, so let me go and configure. So we have two routers here, right? So let me clear the screen a bit. So I call them R11 and R22, right? Great. So what are we trying to do with load balancing is that we will first, right? So we will first show what is called as the equal cost multipath, right? So the two kinds of load balances which is supported in my EIGRP. One is equal cost multipath, which is generally supported by all the protocols, whereas the other one is, other interesting thing which is supported only by EIGRP, is the unequal cost load balancing, right? Before that, let's go and put in some configuration. So we have serial interface 1/1 and 1/0, right? So yeah, let's go and do that. So this is my R1. Probably I can call this host name as R11, right? Similarly, this one is going to be enabled, so this is going to be R1 sorry, R22. all right, great. So we need to put in some IP addresses down here. Let me also put a loopback first. Interface loopback address probably is going to be IP address 1.1.1, right? 255.0.0. okay, and the IP address, right? So for that we will have to go down to, is it it's 1/1 and 1/0. So let's do 1/0 first. 1/0, the IP address is going to be probably 192.1.10.1, right? Let's use this 55.0, no shut. Similarly for my 1/1, so it's going to be almost the same with a slight difference, which is let's use 20.1 for this, right? So the whole idea is to create two different links. So we have two serial interfaces here, just remember that, right? So there you go. So we have done the configuration on one side. Let's do the same thing on the other side as well, right? So let me just actually yeah, I can do this, right? Loopback 0, probably the IP address is 2.2.2.2 should be good, and obviously no shut interface serial interface 1/0. IP address is going to be 192.1.10.2, right? 10.2 and 255.0. I'm going to do a no shut, and the other interface is serial 1/1. I'm going to put an IP address of 192.1.20.2 for this, and there you go, no shot. There you go. So we have done that. All the IP address stuff is done. Yeah. So like I've told you, the default speed, right? The default bandwidth of any serial interface is 1544. I can actually show you that as well. So if I go down to show interface serial, probably let's see 1/0, you can see the default speed, or default not speed, the default bandwidth is 1544, right? And we are going to keep it as default for now, right? Let's go and enable EIGRP on both of these guys. So it's going to be let's come out of this mode. Let's go to router EIGRP 100, no auto summary. What else? You have to advertise the network, so it's going to be network 1.0.0.0, network 192.1.10.0. The other one is going to be 20.0, right? Similarly on the other side, let's clear the screen a bit, exit, router EIGRP 100, no auto, network is going to be 2.0. The other networks are 192.1.10.0 and the other one is 20.0, right? By doing this, you can see the neighborship has come up, right? The EIGRP is running. So if you look at this network, we just have let me actually put this because it's useful. So the loopback here is 1.1.1, right, on this side, whereas on the other side it's going to be 2.2.2, right? Is this okay? We put this here, and this is 2, right? Great. If you go down to my R11 and let's look at the routes, show IP route, right? So if we look at here, the path or the route, it has, the routing table has 2 paths, right, to reach my 2.2.2.2, basically the loopback on the other side, right? So from here, if I want to reach here, there are 2 different paths which I can take, and both the paths are listed here because both of them have the same metric, right? It's equal cost. So every routing protocol, this is basically equal cost multipath, right? So because we have the same kind of interfaces here having the same bandwidth, right? So as a result, the metric also is going to be same, the cost is going to be same. As a result, it's going to do load balancing. So every protocol does this. So if you have equal cost to reach a particular destination network, then every single protocol by default does the equal cost multipathing. So basically here, one session will be basically sent along this path, whereas the other flow or the other session will be sent along the other path, other interface, right? So that's your equal cost. But EIGRP, like I said, also supports unequal cost multipath, right? So now to see this, what we are going to do is we are going to probably change, let's probably make this bandwidth as 512, right? Let's change this to 512, whereas retain the other one as 1544, which is the default, right? Let's change this and let's see. We are basically manually trying to change the cost here, aren't we? So if I have to take this, and so it's going to be 1544 here, whereas the 1/0 interface, we are going to make it 512, right? So let's do that. So we just need to change on the 1/1, right? So let's go down here, serial interface 1/1. The bandwidth is going to be, sorry, bandwidth is gonna be 512, right? Similar case, just go down here on the other one as well, bandwidth 512. There you go. So we have manually changed it, right? So now if you look at your R1 or basically R11, so if you go down here, let's do the same thing, show IP route. You can see here now we don't have two paths, we just have one path, right, which is obviously through the 1544 interface, because the bandwidth is higher over there. But you see there is only one single route now, unlike earlier case where we had two routes because the metric was same. What we did, we manually changed the bandwidth, and that's why the value changed, right? Yeah. So now if you look at this, right, if you calculate the metric, right, just like how we calculated earlier, right, over here, if you calculate the metric, if you so you have two different paths here, right? If you calculate the metric, the value comes up to be, so one of the value for which interface, the bandwidth, or basically let's say uh, the serial interface 1/0, right? 1/1 we have, sorry, we have 1/0 and serial interface 1/1, right? So the 1/0 is the one which is having a better bandwidth. So for this particular interface, the metric comes up to be, I'm not going to calculate again because I've already shown you how to do it. So the metric basically comes up to be 2 million and 297,856, right? Whereas for the other one it comes up to be 5,000,639 and 936, 639,000, right? So these are the two metrics, right? And in the routing table you see you have the path with the serial interface 1/0 because it is having the lower metric, right? But this is how EIGRP works. Though we have only one single path in the routing table, but there's another table called as the topology table, which will have both these paths, because both these routes or both these paths can be used to reach the destination. So if I show you that, so it's going to be show IP EIGRP topology, right? So you can see here the topology table has two different paths, right? The routing table always has the best path. So out of these two paths, you can see this is the one with the least metric. That is why this particular route has been put on the routing table. Whereas you also have the other path, right, with a slightly bigger metric and present in your topology table, right? So the first one is always called as the successor, and the best path or the best route is always considered to be the successor, whereas the rest of the routes are called as the feasible successors, right? And you always put the only one, the best one, on the routing table. So you just need to know that. Now if you look back at the topology, what's happening, all the traffic is actually going along the best path, which is serial interface 1/1. But what if you don't want that to happen, because the other interface is completely idle, it is not doing any job, it's not passing any traffic. So how about you still want to send some traffic on the other interface, right? Obviously you won't be doing equal load balancing because both of them have different bandwidths, but you still want to send some traffic, right? So how do you do that? So that's where you use the concept of variance, right? So now if you divide this particular metric, right, so you take this metric and you divide, let's do that, right? Let's probably do it on my calculator, so I can go down here, right? So it's 569,936. So if I do 569 and 936, you divide that by 5639, my bad. So it's 5639936, right? 36. You divide this by what? By this number, which is 297,856. 297 and 856, right? You see you can see that it's around 2.45, which means my my best route is almost 2.45 times better than the second best route, right? So whenever it is more than whatever is the decimal, right, if it's 2.4, right, which means it's greater than 2 and less than 3. So anything greater than 2, even if it's 2.01 or 2.12, whatever it is, you consider the next number, which is 3, right? So now we go and use the variance command, right? So let's go down to this interface. Let's go down to the router command, router EIGRP 100, right? And you use variance. Variance, what do you use? You use 3. Why? Because you know the difference, or basically the best route is 2 point whatever is, it's greater than 2.45 times the second best route, right? And you always consider round it off to the next decimal number, so you say variance 3, right? So when you do variance 3, now I can do show IP EIGRP. Yeah, sorry, do show IP route, right? So when I did this, you can see once again the other route has been introduced into the routing table. Now carefully observe that this is not equal cost multi-path, because you can see the costs are different, right? The costs are different. Now when the costs were different, by default, you know, you should not have the second route in the table, right? We did the same thing here, right? So you can see there was only one route. But how did we introduce the other route as well? By using the variance command, right? By doing the variance command. Now what I can show you is, let me do show IP route to this network, right? Yeah. So when you see here, you can see that there won't be equal cost multipath happening here, whereas you have something called a share count here, right? So the share count basically tells us that on one path, like for example the fastest path, right, or the best path or the best route is going to have traffic share of 120, which means like 120 flows or 120 sessions are going to go on that particular path. But at the same time, you know, simultaneously there will be only 49 sessions or flows going on the slower or the second best path, right? So what did we do now? Actually, we accomplished what you call as the unequal um, load balancing, didn't we? Right? So we no longer have this particular route as idle. It will still send some traffic, but at the same time, it won't be equally the traffic won't be equally divided. It's going to be proportional to the whatever, to the bandwidth of this particular interface, right? So that was unequal cost multi-path, right? So we talked about a lot of things in EIGRP. We talked about the characteristics, the basic configuration. We talked about authentication, summarization, the manual summarization, auto summarization, filtering. We did not talk much because we have done the same thing in the RIP as well. You can do the filtering of routes using either ACLs or using prefix list. We talked about another interesting mode of EIGRP, which is your named mode, right, which is slightly different from the classic mode. And it's really preferred because, you know, you can do all the configuration of EIGRP under one place rather than doing it under interfaces here, there, throughout the router. Then we talked about leak maps, EIGRP leak maps, how you can leak routes, you know, and again, kind of like utilize some of the idle links, right? So what we did was we summarized all of these routes so that, you know, majority of the routes took this path, but at the same time we leaked one route along this path so that even this route or this interface is not idle. Then we did load balancing. We did two types of load balancing. One is, we talked about the equal cost load balancing, right? When you have two interfaces of the same bandwidth and same metrics, you know, the all protocols by default, they do equal cost load balancing, which means one flow is sent on one interface and the other flow will be sent on the other. But then EIGRP also supports what you call as unequal load balancing, which means though we have you know, different metrics on these two interfaces, right, we have a provision to introduce both these routes into the routing table so that the traffic is unequally shared between these two interfaces, or more than two interfaces also it's possible. But basically you're trying to unequally share the traffic so that you don't keep any links idle, right? So that's all what we discussed. Thanks for watching, guys. Have a good day.